This video is covering Unit 18.4. 18.4 deals with practical applications of complete quadratic equations. Alright, so let's take a look at the first example on top of page 505. It says a commercial building is designed to have an entrance opening with an arch top as shown in figure 18.8. An architectural drafter uses the following equation to determine the height. Okay. So the equation is W squared is equal to 8R times H minus 4H squared. And from the drawing we can see that W is equal to 12 and R is equal to 10. So substituting those numbers in here, I get 12 squared is 144 equals 8 times 10 is 80, so 80H minus 4H squared. So let's get everything on the left side. So 4H squared minus 80H plus 144 equals 0. Alright, let's put our numbers in for the quadratic. Minus minus is positive, so that will be 80 plus and minus the square root of 80 squared minus 4 times 144, all divided by 8. And underneath this radical here, we have 64. So it is 80 plus 64 divided by 8, and 80 minus 64 divided by 8. Alright, so let's see here. 80 plus 64, 18. That one looks kind of funny. 80 minus 64 divided by 8, 2. Okay, so the height can be either 18 or 2. Now, it can't be 18 because the radius is 10, and there's no way that height can be more than the radius. So 2 has to be the number. That's how we deduce between the two answers. Now sometimes there is no deducing between the two answers. Let's take a look at example number 2 at the very top of page 506. From physics, the formula H equals VT minus 16T squared, where H is the height, V is the initial velocity, and T is time, and 16 is a constant. Dealing with gravity. Okay, so A. Determine the time in seconds it will take for an object to reach a height of 115, so height is equal to 115, when it is thrown upwards at a velocity of 92 feet per second. So velocity is 92. So put those numbers in. 92 times t minus 16t squared. Let's get everything on the left side. So 16t squared minus 92t plus 115 15 equals 0. Negative negative makes it a positive, so 92 plus and minus 92 squared minus 4 times 16 times 115, and that's all under the radical, divided by 2a, which is 32. Okay, so let's find out what's under that radical. So 92 squared minus 4 times 16 times 115. That is 33.23. Okay, so that means we have 92 plus 33.23 divided by 32, and we have 92 minus 33.23 divided by 32. Alrighty then. Let's have some fun. Fun with physics. 92 plus 33.23. Put a 32 in the bottom. And we get 3.9. Then we go 92 minus 33.23. 32 in the denominator. And we get 1.8. 1.8. Neither one of these is negative. Okay, remember we talked about this. The way we determined which one was right was the negative one was the one we got rid of. Well, both of these are positive, so what's going on here? But now if you look at the problem, what's happening is the object is being thrown into the air. So it's starting right here, and it's being thrown into the air. So when you throw something into the air, eventually it's going to peak out, and then it's going to fall back down. And this initial velocity going that way, in this case, is 92. Well, it looks like, from what we've got here, somewhere up in here is 115. So as the object, I don't think it says what it is, it doesn't matter. As the object is going up, it reaches 115 on its way up, and it looks like it takes 1.8 seconds to get there. And then it peaks out and starts falling back, and on its way back, it hits 115 again, and it takes 3.9 seconds to get there to this point. 3.9 seconds from the beginning. So that's where the two answers come from. One of them is on the way up, that would be the short time, and one of them is on the way down, that would be the long time. So this is one of those physics ones where the two answers are both correct. And I know that because, first of all, they're both positive, so that throws a hint to me. And also, the object is thrown up rather than dropped. Okay, let's see here. Was there another one that we wanted to try in this one? Not really. We'll do a couple more of these in the next section.